Kia ora and welcome to video 9 of Agile Algebra. This video has another problem that involves a little bit of a trick. Seems pretty nice on the surface. We've got a function, a polynomial with degree 10, and all we need to do is substitute the square root of 2 minus 1 into it and get the value. And of course, if you think about doing that, it's going to be really, really tedious. Of course, you can't just use a calculator. So have a go at it, think about types of tricks that you could use. It uses level 3 algebra knowledge, and that's all I'm really going to give you. Solutions on the other side of the intro music. All the best. Okay, here we have a polynomial of degree 10, and we're asked simply to substitute the square root of 2 minus 1 in. Yep, it's something you can again use your calculator for. There's a common theme in these videos that I've been doing. If you take the square root of 2 minus 1 and then chuck it into all the x values, use your calculator, you'll get the answer that you're looking for. If you were to do that manually and show you're working, if this was a scholarship question and you needed to show where you're working, you'd probably get stuck in the fact you needed to find the power of a 10. Right? So root 2 minus 1 to the power of 10 is a bit tedious, and then I've got to also power it by 9 and 8 and so on. So there must be a trick. Now if I consider x equals the square root of 2 minus 1, or even better, x equals plus or minus the square root of 2 minus 1 as an x value. And this is the x value that I want to substitute into this polynomial. Then if I rearrange this equation, x equals 1, x plus 1 equals plus or minus root 2, square this, square both sides. This is like reverse completing the square. I get x squared plus 2x plus 1 equals 2, and then I get this quadratic x squared plus 2x minus 1 equals 0. Now what I can do with this quadratic is I can try and factor this polynomial using that as a factor. So I take my polynomial, which is degree 10, tedious to write it all down, and then I'm going to use this factor here which I've just generated, and I'm going to try and factor this. Now the reason for it, which you maybe pause and think about why I've done this first before I give you the reason. The reason for it is that we know with this x value that when we substitute it in we get 0. And so if I substitute this x value into this whole bracket, I'll get 0, meaning it doesn't matter what the other bracket is, I don't even have to evaluate it. And then the answer at the end, whatever the remainder is, will be the only thing that I actually need to substitute this x value into. So I'm saving a whole heap of substitution time. Okay, let's get rid of the highlighting. Okay, let's start off with an x to the power of 8, because that will make an x to the 10. That's also made a 2x to the 9, which is great because we wanted that. It's made that, it's made that, and it's made a minus x to the 8. So it hasn't quite worked with the x to the 8s. I needed a minus 2x to the 8, and I've only made a minus 1x to the 8. So if I go minus x to the 6, when it comes to this term here and that term they're combining, I've got a minus x to the 8 and another minus x to the 8, making minus 2x to the 8. So that's that term done. I've also made a minus 2x to the 7, which is great, and I've made a plus x to the 6, which is also done. So now I've just got to try and make that quadratic term 3x squared. So if I put a plus 3 there, that's going to make 3x squared. It also makes 6x, but it makes minus 3, and I wanted plus 1. So that's the remainder. Well, that's how we work out what the remainder is. We've got minus 3. If I add 4, this term at the end, the remainder, will make the polynomial balance and make them plus 1. So I've made all of the polynomial terms there. And like I was saying, if I now substitute in sub in x equals root 2 minus 1 into the polynomial, I'm going to get f of root 2 minus 1 equals 0 times stuff plus 4. So the answer to the question is 4. Of course, I could have got that with my graphics calculator and cheating, but that's a really, really nice algebraic solution there that gets it without any tedious substitution.